All right, welcome back. We are going to do this code challenge again, see if I get any further, see if I can explain it better, see if I can approach it better, knowing what I know of how it sort of should work and trying to solve it. So I copied over some of my tests that I had added before, and I want to go through what this is going to look like. So let's just look at the test because this is the first thing that I was thinking about. So the least common, sorry, I say this wrong. LRU is last. Let's change our font color. Last, recently used LRU cache. That's what we're working on. This is what I failed. This is what I failed multiple times. And so I want to get better at it. So we're going to practice it. Now, I'm going to set a timer. I think there's two approaches. I think I could use, and this is the trick. So let's just talk about what that is. You need to use, for the optimal solution, you need to use a double linked list and a dictionary or map. In Swift, it's dictionary. Okay, so that's one solution, is going to have those two. And then the other solution, I'm pretty sure I haven't implemented it. This is what I did in the interview because I was thinking on the fly, like, how can I do this? How did I do this? How did I do this? I think you can use an array in a dictionary. And it's a fixed size array that's going to have fixed number of elements. And then you have to track the last used element, so or most recent, and you cycle through. So it's going to cycle. So there's an array and there's a dictionary for instantaneous lookups. Both of these, I think, still need to have some kind of node that has a next and a previous, and then the data, which is going to be the value. Or in this case, it's just self, I think. No, it's going to have a value. Okay, so that is, I think, the starting point. So I'm going to do number one. I'm going to try and do the double linked list in the dictionary. And the other way I'm going to approach this is I want to think, so let's talk about my style here. Now let's zoom in. So the things that I want to focus on are explain problem in less than 5 minutes. So with diagrams, right? That font size too big. Oh, don't do that. Let's see if we can do this. I need to change the erase tool. There we go. Okay. So I want to be able to explain the problem within 5 minutes. So I have to time block that. Next, I know on average, so just so that you're aware, I probably spend 7 to 10 minutes in this area, which is a little bit too long. I need to jump into code sooner. But before we do that, I think confirm with interviewer if that makes sense. So just making sure that you're on the same page, that you're not solving the wrong problem, because that's the other thing is there's nuances to all these problems, and they might have like a slight tilt on which way this problem is going to go, that changes how you might approach it. So I think just having the conversation, they want you to be talking. Talk. So we're going to talk. We're going to practice. That's what we're doing in this video. The other thing, I want to try and do test-driven development as much as possible, which I think is going to change my approach to solving it. And I don't know if this is going to take too much time. So like, this is an unknown. But I want to have tests that pass early. And that means designing the code, write the code to have something working. Okay. The issue that I had in this is that I approached it first of trying to make the doubly linked list and then doing the caching with the list, but I didn't have anything working until the very end. And so what I want to do is make it so that the cache works first. So for this problem, we're going to approach this with tests in mind. And that means that if we're making a cache, the most important thing is that this is a cache first. So to have something that works, we're going to focus on the dictionary approach and caching values. And then we're going to test that. Okay. And then after that, after we know that that's working, then we have to focus on our second. So this is our first. This is going to be our second, which is the last recently used portion. So we need some way of tracking last used, but that is like an enhancement. This is an enhancement on the core functionality. So we're going to set that up, and then we're going to test that. And there's a ton of edge cases. I don't think you can solve all of them there's no way you can solve all of them in 15 minutes. But this is going to require a linked list. So you have to be comfortable with that. So if you're not comfortable with linked lists, you need to practice that. And I'm not, I'm out of practice. So that's why it took so long. But in order to, there's another trick in here, and I'm probably going to rediscuss this, but when we insert into, let's change that. When we insert, that's going to mark an item. And let's go white. Okay, so that's insert. So when we insert, the item is the last used. So if we had a diagram here, let's not do that. Okay, so if we're pretending this is a linked list implementation, this is going to be our head, and this is going to be our tail. I'm always going to append to the tail. So append to tail. And so like that's fine. The thing that makes you need a doubly linked list is the read. And what did they call it? I forget what they called it. So we'll just call this, it's right. So this was called right. And oops, that's nil. So item is the last used. You remove the old items and you append to the tail. So that means the most recent is this. So we're just looking at this portion, and then this is the last recent. So understanding this makes this dramatically easier. It's the read that I think I missed this in the Zillow interview. I wasn't even thinking about it, but this is a cache hit. So this is showing that we care about this element because we're pulling it up again. So that means that we have to say that this item is last used. And we don't remove any old items because there's nothing to remove. But this does mean that we have to adjust pointers. And that means that we have to move wherever this item is to the tail. So move to tail. And the key takeaway for this portion is like it's easy to just delete the node. So let's say this is the one, let's say we wanted to grab, if we want to read 3, what that will do is effectively, let's change the color. I'm bad at undo. Okay. So if I wanted to read 3, we'll choose a new color. What I'm going to do here is I'm going to remove 3, and then I'm going to reinsert it. And in this case, this gets updated to point to 3. 3 now points to nil. Tail now points to 3. And our most recent is now 3. How do you do that with the linked list? Now, if we're using a doubly linked list, if we're using a dictionary and a single linked list, I need to be able to, the problem is this connection, this is our next. I need to be able to say, okay, the thing that was before 3, and let's say that's 2, and then this is 7. I need to have 2 point to 7. In order to do that, I need to know what comes before 3. But if I just use a dictionary to look up 3, then 3 doesn't know anything about who its parent is, where it's coming from. And so that's why we need the doubly linked list. And so our dictionary, the key takeaway for the dictionary in this case is going to be, let's use white. It's not any old dictionary. And that's the takeaway here. We need to have key to nodes so that we can get to things. And then our doubly linked list, we need to have nodes that have the node needs to have a previous It needs to have a next, and it needs to have a value, whatever that's going to be. So that our structure is now going to have this arrow going back like this. I guess in my diagram, that one went away. But then we're going to, whoops, don't do that. This has a back arrow. So if we're looking at this, this is our next, and this is our previous. And that's important so that we can do the delete. So that means when you approach this problem, not only do you have to have a doubly linked list, but you need to support delete. You need to support insert. This, in this case, it's insert, not reinsert, but that's the action that we're doing. Append is essentially insert. So let's say that's append. So just thinking about the concepts. So like I would try and think about the concepts, understand how to approach it. And this is just for the doubly linked list approach. This is not the array approach. That's like a fixed size array that's always looping, because the cache is going to have a fixed size. So we could allocate an array of a fixed size. The other thing is I'm going to be using classes, not structures. And then one other key thing is you want to prevent a retain cycle. This is what I also messed up. So if we're doing that, I'm going to make weak our previous pointer. So this is going to be a strong reference, and then the other one's going to be weak. So prevent retain cycles. Okay, so that's kind of like my summary notes. I hope this is helpful to sort of think about this problem. There's definitely a trick to it. And the other trick is getting it to compile. Now, on top of that, I have another video that talks about the associated types, because if we look at the implementation that we're starting with in this problem, we're going to have a cache item that's a protocol. It's going to have associated type of key. We have a key attribute for a cache item. So every cache item has a key. Then we're going to have a protocol for a cache, which has an associated type of items that are cache items. So that's referencing this. So now we have an associated type that is constrained to cache item. It's of size t, which is the max size of the cache. So you go over that, you start ejecting things from the cache because they're the last recently used things. Did we talk about it? Yeah, we talked about that. So that's our delete. But that's on insert, remember. And then we're reading, we're giving an item back of type optional because it may or may not exist. When we're writing, we're not returning anything. So like that's our public interface. And then for the example, we have two different types conforming, and they conform, and it does this implicit associated type. So they don't actually specify this, but it sets up the associated type up top. It's going to be of type string for this one and int, and then we're just returning self. But you could imagine this being an actual image or some kind of hard to create resource, JSON file or something that has an actual key, not just itself. So this is a little contrived example, but you should be able to then use this for real things if you do this right. Then we have my cache down here, which is going to have items. And now we're making it generic. And so just understanding that we have associated types and protocol conformance up top. Now we're taking that a second step further, which kind of makes my mind like spin in circles sometimes. And I'm always fighting the compiler on these. And I fought it when I was trying to implement this the last time. And this is going to have cache items. So cache items is what we defined at the top, is just something that has a key. So all we know is that an item has a key, and we can always read that. So then we have our item, which is, now this is our generic type item. So the generic type item, since it's a cache item, has a key type. We see the type up top. So that's the associated type, which has to be hashable. Both int and string, both of these types are hashable by default. So we get that automatically. And so that is our type. That's our associated type key, which is used to define the property key. And we implement that for read and write. So that is the starting point for this cache. We've got protocols, protocol conformance, associated types related to the protocols. We've got, and then generics. And generics to make it so that we can have different types of cache items. So we could have strings, we could have ints, we could have images. And as long as they have some key attribute, they could all work. All right, so that's the starting point for this. Let's dive into the actual